Hello friends, Mr. Burrell here. We're starting a fresh new unit. We finished talking about everything about regular polynomial functions. Now we're going to go on and kind of extend that to talk about rational functions or rational expressions, specifically solving rational expressions. I mentioned at the beginning of the year it's all about solving functions, solving equations when we come to this algebra part of Math 3. So we've talked about basic polynomial functions, a bunch of different kinds. Now we're going to go on and talk about rational expressions and solving rational expressions. That's all what Unit 5 is about. If you don't know what rational means, we'll get there in just a minute. So this first lesson is going to be on simplifying rational expressions using the greatest common factor. So we have used the greatest common factor. We know how to find the greatest common factor. So we're going to talk about simplifying rational expressions using that tool. So objectives, by the end of this lesson, by the end of this video, I hope that you're able to find the greatest common factor of a polynomial, which you should already know how to do, and factor a trinomial, which you should already know how to do. We spent several lessons in Unit 4 talking about factoring quadratic expressions, which are trinomials. Beyond that, I'm wanting you to be able to simplify rational expressions and find excluded values of rational expressions, and we'll talk about rational expressions and excluded values and what all those things mean. So, some definitions. These definitions right here are not new definitions. To factor as in the noun factor, is a number or expression that divides the product exactly. So the example I've used in the past is like the number 16. A factor of 16 would be a number that divides perfectly into 16. Like 1, 2, 4, 8, 16 are all factors of 16 because they all divide perfectly into 16. We talked about like factors like of 3x squared or of, let's do 6x squared. I would have the factors 3 times 2. 3 and 2 both perfectly divide into 6, as well as 1 and 6. And then x and x both perfectly divide into 6 because x and x make up x squared. So factors are numbers or expressions that divide the product exactly. Factoring, when I'm talking about factoring in the verb sense, I'm rewriting a polynomial as a multiplication expression instead of as solely an addition expression. So again, when we've been talking about factoring quadratics, we would take a quadratic from this form, standard form, and write it instead as a multiplication problem. Two sets of parentheses multiplied together. That's what we did when we were factoring. The greatest common factor was the greatest number and or variable that was a factor of 2 or more terms. So when I came up here and I wrote 16 and 12, if I wanted to find the greatest common factor between 16 and 12, it would be 4. The GCF, or the greatest common factor, would be 4 because it's the largest number that divides into both of those terms. Again, all that is not new information. We're going to be utilizing those definitions and those tools as we start to talk about rational expressions. So, rational. When I say rational, I'm talking about a number, quantity, or expression that can be expressed as a ratio. See this root word here, ratio? When I say an expression can be written as a ratio, I'm talking about it can be written as a fraction. So 1 over 2 would be a rational expression. 3x over 7x would be a rational expression. 2x plus 6 divided by 3x squared minus 7x plus 4 would be a rational expression. Anything that can be expressed as a fraction. When I talk about simplifying, I'm talking about reducing a fraction to its lowest terms by canceling the greatest common factor for both the numerator and the denominator. So when I'm simplifying a fraction, a simple example is if I had, say, 2/4. 2/4 is a rational expression, but I can simplify that because 2 can divide into both the numerator, or the top, and the denominator, the bottom. So 2/4, since I can divide both of those terms by 2, can reduce to 1/2. So we're going to see how rational expressions with variables and full polynomials can also be reduced by dividing by the greatest common factor. And last but certainly not least, an excluded value is any x value that would cause you to divide by 0. You've probably heard in the past that dividing by 0 is a big no-no. You cannot divide by 0. It doesn't work. Mathematically, it's impossible. If you have questions about why that's the case, come talk to me. But you can't divide by 0. So any x value that would make that happen, we're going to call an excluded value. So if I find a solution that makes a fraction divide by 0, that solution is an excluded value. So to find an excluded value, we will set the denominator equal to 0 and solve for the variable. We'll use the factored form. This is in bold for a reason. We're going to use the factored form before anything is canceled out or simplified. So before we're able to cancel or simplify an expression, we're going to find excluded values. So let's put all those steps into effect with some sample problems. So this question says, simplify the following rational expressions and state the excluded values. So I have this fraction, negative 16 divided by 24. If I were to divide negative 16 into its prime factors, so if I were to break down 16 into its prime factors, I'd get 4 times 4. I'd get 2 times 2 times 2 times 2. So 2 times 2 times 2 times 2, since it's a negative 16, times by negative 1. Now on the bottom I have 24. If I break 24 down into its prime factors, I have 1 times 2 times 2 times 2 times 3. That was up here, right? I found that by taking maybe 6 times 4, 3 times 2, 2 times 2. So 1 times 2 times 2 times 2 times 3. That is the prime factors of 24 on the bottom. So to simplify, I'm going to, if there are any similar numbers, if I go back here again, simplifying is reducing a fraction to its lowest terms by canceling the greatest common factor for both the numerator and the denominator. So the greatest common factor in the numerator and the denominator would be these 3 2's. Those 3 2's are in common in both the numerator and the denominator, so I can cancel them out. All those cancel each other out. 2 times 2 times 2 is 8, so you'll notice, again, I can divide by 8 in both the numerator and in the denominator, get rid of those, and I'll be left with negative 1 times 2 in the top and positive 1 times 3 in the bottom, which gives me negative 2 over 3, negative 2/3. That's the reduced fraction of this fraction right here. So that's kind of a review of what you did. I think we talk about ratios and fractions a lot in like 6th grade. So this is kind of a basic review of how you would simplify fractions. The last part of this problem says state the excluded values. Reminder, the excluded values were any x value that would cause you to divide by 0. Well, I don't even have any x's in this problem, so I don't have any excluded values. We'll talk about that on the next question. So, I now have a problem that says x cubed divided by x. X cubed divided by x. So I want to simplify that rational expression and state the excluded values. So x cubed I can write as x times x times x. X in the bottom I can just write as x. And the greatest common factor between both the numerator and the denominator is an x. So I can cancel out those x's. I can divide by x on both the top and the bottom. And all I'm left with is x squared on the top and nothing on the bottom. So just divided by 1, or I'll just leave that as x squared. So my simplified expression is x squared. I divided by the greatest common factor in the top and in the bottom. So now we're going to talk a little bit more about stating the excluded values. So notice, before I simplified, in the excluded values instructions, I said we need to use the factored form before anything is canceled out or simplified. So if I go to this expression before I canceled anything out, notice that I have an x in the denominator. So in order to find my excluded values, when I have my factors in the denominator, I'm going to set them equal to 0. In this case, when x is equal to 0, notice that I'm going to be dividing by 0. If I put 0 in here for x, I'm dividing by 0. I can't do that. I can't divide by 0. So my excluded values are going to be x equals 0. I cannot divide by 0. I cannot do that, so my excluded value is going to be x equals 0. Because if I put 0 in for x, it forces me to divide by 0. Okay, let's look at another example. 12x squared divided by x to the 4th. So if I find the greatest common factors of the factors of 12, I can break it down something like this. So I have 1 times 2 times 2 times 3. And then times x. I have x squared in the top. If I break down 48, I get 12 times 4. 4 is 2 times 2. And 12 is 4 times 3 and 2 times 2. Notice there, you can start to see what our greatest common factor is going to be. So I have 1 times 2 times 2 times 2 times 2 times 3 times x times x times x times x. So you don't have to do this every time, but I'm going to. I'm going to write out all my prime factors. So notice now what I have in common between the top and the bottom. I have this pair of 2's and this 3, and I have 2 pairs of x's. So all those I'm going to be able to cancel out, and I'll be left with 1 in the top and 1 times 2 times 2 times x in the bottom, which gives me 4x squared in the bottom. So my simplified solution is 1 over 4x squared. I'm halfway there. So if I go back here to finding the excluded values, again, any x value that would cause you to divide by 0 is an excluded value. So, looking at this, let me try to erase these things without erasing the variables. Looking before I simplified anything, look at what I have in the denominator. I have these x's. I have 4 x's, in fact. So, because those x's are in the denominator, when I set them equal to 0, my excluded value is going to be x equals 0. X cannot be 0, or else I would be dividing by 0, and I can't do that. I can't divide by 0. Okay, so those are kind of the first basic ones. Let's look at some slightly more involved ones. So now instead of just like monomials, individual terms, I'm going to have full-on polynomial expressions. So here I have 2x plus 2 times 3x plus 3. So first, in order to try to simplify this, I want to see if there's a greatest common factor in the numerator and in the denominator. Okay, let's look at my numerator. Between 2x and 2, what is a common factor I could take out of both of those terms? Well, I could take a 2 out. 2x divided by 2 is x. 2 divided by 2 is 1. So if I factor out that numerator, or the top of that fraction, I get 2 times x plus 1. If I factor out the bottom, notice between 3x and 3, I can take out a 3, and what I have left is x plus 1. See here what's happening. I have 2 times x plus 1 in the numerator, 3 times x plus 1 in the denominator. So when I'm simplifying, I want to see if there's a greatest common factor between the top and the bottom. Here's a factor, and note that I have the same factor, a common factor, in the top and on the bottom, so I can cancel those out. So when I cancel those out, I'm left with 2 thirds. 2 over 3. I factored out the top and the bottom of this fraction, found that those factors were common, so I could cancel them out or simplify, eliminate those. So I'm left with 2 thirds. My simplified answer is 2 thirds. So that's the first part of this problem, again, simplifying the expression. Now I need to state the excluded values. So before I cancel anything out, I need to look in the denominator and see, set the denominator equal to 0, the factors in the denominator equal to 0, and see if there's any place that would make the denominator equal to 0. So say I put x plus 1 equal to 0, because that's a factor with an x in the denominator. If I set x plus 1 equal to 0, I'm going to go ahead and subtract 1 on each side. I'm going to get x equals negative 1. So when I put negative 1 back in here for x, that turns into negative 1 plus 1. 3 times negative 1 plus 1. Negative 1 plus 1 is 0, times 3 is 0, which would cause this whole expression to be divided by 0, which is a no-go. So x equals negative 1 could not be a solution to this expression. We're going to talk about solving these and finding the solutions later on. But x equals negative 1, we know, could not be a solution because it would cause this equation to divide by 0. So x equals negative 1 is an excluded value. Let's look at example 5. In the numerator, can I take out a greatest common factor? Well, I can take out a 2 out of both of those and be left with x plus 2. In the bottom, is there a greatest common factor? There's not a greatest common factor, but this is a quadratic expression. I can factor a quadratic expression and split it into 2 individual factors being multiplied together. So note here, A, B, and C, I need to find 2 numbers that multiply to make a negative 8 and add up to negative 2. Well, what are two factors, or two numbers that multiply to negative 8 and add up to negative 2? Well, I have negative 1 times 8, negative 2 times 4. I have 1 times negative 8, 2 times negative 4. Well, look at this. 2 plus negative 4 is negative 2. 2 times negative 4 is negative 8. So those are my numbers. So in my factors, I have x plus 2 and x minus 4. And using kind of the shortcut that we established in Unit 3, that's as far as I need to go. That's as simplified as I need to do, because each of these would be divided by 1, which is uninteresting. Anything divided by 1 is itself. So those are my factors. 2 times x plus 2 divided by x plus 2 times x minus 4. Let me erase this. Now, are there any factors that are in common on the top and on the bottom? Well, notice I have an x plus 2 and an x plus 2, so those could cancel out. And I would be left with 2 over x minus 4. That would be my simplified expression. So that's my answer. That's my simplified expression. I also need to state the excluded values, or what values of x would make the denominator equal to 0. Well, I have x plus 2 in the denominator, so I'll set that equal to 0. I have x minus 4 in the denominator, I'll set that equal to 0. Solving for x, I'll subtract 2 on both sides, add 4 on both sides. I get x equals negative 2 and positive 4 as my excluded values. So those are numbers that could not be solutions because they would make you divide by 0. Those are excluded. Those would not work as x values. Okay, so I did one where I just needed the greatest common factor in the top and the bottom. This one I got the greatest common factor out of the top, and then I had to factor a quadratic in the bottom. This one I need to factor a quadratic in the top and in the bottom. So there will be some of all these varieties on your homework assignment. So x squared plus 6x plus 8, I need to find two numbers that multiply to make 8 and add up to 6. Two numbers that multiply to make 8 and add up to 6. Well, I have 1 times 8, 2 times 4, negative 1 times negative 8, negative 2 times negative 4. Well, 2 times 4 is 8, and 2 plus 4 is 6. So my factors are going to be x plus 2 times x plus 4 on the top. And on the bottom, I need to find two numbers that multiply to make 16 and add up to 10. Two numbers that multiply to make 16 and add up to 10. Well, 1 times 16, 2 times 8, 4 times 4, and alas, 2 times 8 is equal to 16, and 2 plus 8 is equal to 10. So I have x plus 2 and x plus 8. I'm going to erase these now. So I have my two factors in the numerator, or in the top, and my two factors in the denominator in the bottom. So are there any common factors in the numerator and in the denominator that I can cancel out? Well, yes, I have an x plus 2 on the top and on the bottom, so those can cancel out, leaving me with x plus 4 divided by x plus 8. So that is my simplified expression. Notice on some of these I've been dropping the parentheses as I go. When I'm no longer multiplying by anything else in the top and in the bottom, the parentheses become null and void. I don't need them anymore. So that's my simplified expression. Now, let's state all the excluded values. Or in my original expression here, before I simplified, what values of x would make the denominator equal to 0? Well, I have to set x plus 2 equal to 0, and x plus 8 equal to 0, because those are both factors in the bottom, or in the denominator. So I'm going to, on this one, I'll subtract 2 on both sides and get x equals negative 2. This one I'll subtract 8 on both sides and get x equals negative 8. So my excluded values are x equals negative 2 and negative 8. Those are values of x that would not work, because when I put them into this expression, they make the denominator equal to 0. So this is the end of this lesson. That's simplifying rational expressions. We're going to go on and start talking about other things that we can do with rational expressions, like adding, subtracting, multiplying, dividing. We're going to talk about solving rational expressions. But for now, I want you to be able to find the greatest common factor of a polynomial and use those greatest common factors as well as factoring trinomials, factoring quadratics, to be able to simplify rational expressions and find excluded values. So that's the end of this video. I hope that was helpful. Please reach out to me if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.